Okay. Okay, we are doing multiplication of rational expressions today, which is really not all that different from simplifying. The only difference is that you have two separate rational expressions being multiplied together and simplify each of them and then cross out stuff that matches. Same thing almost as what we were doing before. Yeah?
So you multiply it and then you break it down again.
I'd say simplify then multiply. Yeah. Okay, so in this first one we have 5r over 3t times w over g. Is there anything that can be reduced in any of this madness? No. So if that's the case, then literally all you're doing is like smashing the two of them together. So you smash the two of them together. On the top, you would smash together 5r and w, so you get 5rw. Bottom, 3t and g. I put that one in there because you will inevitably get something like that that can't be reduced and people get confused. So, yeah.
Do you have to rearrange the variables enough that
You don't have to. No. You can, though, if you want to get in that habit. Other questions? All right. The next one. All right, so here's what we're doing. We want to look at each numerator and each denominator and simplify, aka factor, each numerator and denominator. So does anybody see anything that can be factored here in any way, shape, or form? Can the 3 be factored? No. Okay, so let's leave the 3 alone. Okay? Anything else? How about this denominator? Can that be factored? What can be factored out of x squared and negative 3x? Okay, and we're left with what? Good. Okay. Can anybody see any other numerator or denominator that can be factored in any way? Marcy?
the numerator of the second term is you could use the diamond shape to...
Okay. Good. So what? Go ahead and fill it in for me. What do I get?
So negative 6 would be at the top.
Good.
And then negative 1 would be at the bottom.
Okay.
It would be negative 3 and 2.
Okay. And what goes on the top of each of these? An x.
So the top term, the numerator would be x minus 3 and x plus 2.
Good. Excellent. Sorry, I know that's a little hard to see. So x minus 3 and x plus 2. Okay. Now, bottom, right, Lydia? Good. Excellent. Okay. So now, let me just write what we have left here. X minus 3, and you can obviously skip this step if you want to just start canceling things out. X plus 2, 3, x plus 2. All right, so now we are canceling out things that match in the numerator and denominator. Josephine.
X plus 2.
Okay.
3.
X plus 2, 3. Good. Anybody see anything else that can be canceled? Rachel? X minus 3. Good. Okay. Now what? Michael? Good, we got that. Excellent. So we're left with an x. So is my answer just x? What is it? y1 over x instead of x. Good. It's in the bottom of the fraction, so we keep it there. That's pretty much the extent of what you guys are doing today. Questions? Yeah.
What if we wrote that as a negative?
Unless you have a negative on the top to go with it to make it equivalent to this, it doesn't work. Okay? So I'm guessing maybe you wrote it down with a negative.
No, I got 1 over x.
Oh, okay. Other questions? Okay, then let's do another one. I know how much you love these. Okay, anything that can be factored here? Josephine.
The first one, the x plus 8.
Okay. That's good. Both of them can. Perfect. Do you want to do one of them or no?
Yeah. At the top is 8.
Okay.
And then the bottom is 6.
Good.
And then it's 4 and 2.
Good.
And then on the top is x.
Good. So this is x plus 4 and x plus 2. We haven't been cheering for people. Everybody give it up for Josephine. And everybody else who already participated. Equal opportunity. Kendra. Uh-huh. Good. Good. x and x. So we get x plus 1, x plus 3. Everybody give it up for Kendra. Okay, on the right-hand side, can x plus 3 or x plus 2 be reduced in any way? Or factored? No. Okay, cool. So let's leave them. X plus 3, x plus 2. Okay? Do you guys want me to rewrite it, or can we just see from here that we can cancel stuff out? What? Cancel? Okay. Lydia? What? Which ones? Good. Okay, the x plus 3s. Give it up for Lydia. What else? What else can be canceled? Ashley. X plus 2. Everybody give it up for Ashley. Okay, I'm going to play devil's advocate here. Oops. 1. 1, 1, 1. It's not 4. Okay. Anybody know what... No. No is the answer. Anybody know what question I'm going to ask? Look at what we have left. X plus 4 and x plus... Okay, so what is the question I'm going to ask? Okay, you're telling me the answer. I can't cancel out the x's. Why can I not cancel out the x's? Okay, somebody explain it to me as if I have never heard it before for 5 extra credit points. As if I have never heard it before. You're explaining it as if I'm like a 5-year-old. Jade, go ahead.
Okay, time out. But what if I explain it to you, but then it's not a very good explanation? Do I still get 5 extra credit points?
Try your best.
Okay, so you cannot cancel out the x's because the x's is in an individual term with the x plus 4.
Good. Okay. Yeah, scratch the 5-year-old piece, because you're good. So same thing with the x plus 1s?
Yes.
Excellent. Everybody give it up for Jade. Nicely done. Okay. Individual units. Individual units. X plus 4 is different from x plus 1. All right, how are we doing on questions? Good? Oh, my. Okay, here we go. Okay. A cubed plus b cubed. Lots of a's and b's here. I've stunned them. There are literally people in the audience that are going like this. Okay, what do I do here? Look, anything that can be factored. Kendra. The top one, sum of cubes. Cool, everybody give it up for Kendra. So, the sum of cubes. Now, who remembers how to factor that? Remember those lovely formulas I asked you all to memorize? Marcy?
Is it a minus, or a plus b?
Good.
Parentheses. Then it's a squared.
Uh-huh.
Plus ab.
Is it plus?
Or minus ab.
Minus ab. Good.
Plus a plus b to the square.
Excellent. Give it up for Marcy. Okay. Let's do this other one. Anybody recognize anything else? These are actually all forms that we memorized a while ago. Jared?
The a squared minus 2ab plus
Good.
b squared, wouldn't it be a minus b and a plus b?
Ah, it would be, that's one of them, but not this one. That's actually a perfect square trinomial and factors like that. Very good. Everybody give it up for Jared. Okay, now, he mentioned a plus b and a minus b. Stacy? Yes.
So for, like, at the, like, before we do the memorization,
Yeah.
so why can't we simplify the expression so we do a on the top? We learned simplifying rational expressions.
Yes.
Why can't we do that?
Oh, like simplify this?
Yes.
Can this be simplified the way that it is? Can somebody explain to me why I can't simplify this first? Actually, that's technically what we're doing, is simplifying it first. Simplifying meaning getting it into a form where we can reduce things. It's along those same lines of what Jade was explaining, which we can't cancel these out to get a, like, minus b or something because of what? Why can't we do that again? Lydia? They're their own units, yeah. So anytime you have them separated by anytime you have a term separated by a plus or a minus, you can't just go canceling out. They have to be multiplied to do that. Okay. What else? Kendra? Yeah. Excellent. Give it up for Kendra. so we have difference of two squares here, factors like that. And we have perfect square trinomial up here, factors like this. And we have a sum of two cubes here, which factors like that. What about a squared minus ab plus b squared? Lydia? Yeah. Okay. I like questions like this. Right. Right, except that remember our goal is to, we want to reduce this fraction as much as possible. To reduce it, we want to get out anything that matches in the numerator and denominator, and we can do that when things are multiplied by each other. Only when things are multiplied by each other. Oh, what is the point of factoring? What is the point of factoring? Okay. You want the long answer or the short answer? Okay. Right now what you guys are learning is the mechanics of how to do something like factoring. What's going to happen is you're going to, all of us are going to continue to progress on and on. You're going to be faced with real life situations where in order to find whatever the information is that you're trying to find, let's say that, okay, work with me on this example. Let's say that somebody is starting at one point and they are throwing a ball across a field and they want to know how far away that ball ends up going. One of the ways that you can do that is by factoring, setting up an equation for the parabola and figuring out where the intercepts are, assuming that one of them is at 0. Does that help? Jared? You can just measure it, yes. I know, somebody. Yes, rulers are great. That was not the best example. Yes, true. There will be situations where this is the kind of math that's like super abstract that you have to bring back down to something that is less abstract. Wasn't that a good explanation? It is, yeah. So I actually used factoring a lot when I was in engineering, designing structures and whatnot. Okay, so let's get back to this problem. What now? Are we done? Are we done simplifying? Or can we do more? Ashley? Right, you can't. If you wanted to try doing... Okay, nobody should be talking. If you wanted to try doing a squared minus ab plus b squared using a diamond, you could try it. But what would happen is 1 times 1 is 1 and negative 1. Nothing fits in there. So that, we're done. Okay, so now we want to go through and cross stuff out that matches. Jade.
Okay, so if you brought down the a and the b, wouldn't the a and the b equal the middle one? So you could do, or you have to multiply it by 2.
Oh, this?
Yeah.
Yes, correct.
Oh.
It would have to be multiplied by 2, in which case it's like the top. Right. Yeah. But, who knows, it might cancel out. Anybody see it cancel out with anything? No? There aren't matching a squared minus ab plus... Okay. Good. Michael? The whole not pretty looking expression. Good. Okay. What else? What else can cancel out? Haley?
You can cancel the a plus b on the top and the bottom.
Excellent. Okay. Anything else? Anything else? Jared? A minus b and one of the a minus b's on the top. So what are we left with overall?
A minus b.
A minus b. All right.
Over 1.
Over 1. Do we have to put it over 1?
No.
That's good. Okay. How are we doing on questions, you guys? Okay. Would you like to do this problem as a group, or do you all feel comfortable?
I don't want to.
The only reason, hang on, bear with me for like 30 seconds. The only reason I put this one in here is because this, I want to remind you that we have something called factor by grouping. That is how you tackle something like this. So you group together 2 and 2. Now with that knowledge, are you all good?
Yes.
Yes? Show an example of the factor by grouping? Yeah, so let's look at this one specifically. If the first group is 2pq plus p, and the second one is negative 6q minus 3, within the first group, 2pq plus p, what do they have in common? A p. And I'm left with what? 1. Good. Okay, how about in this group? What do they have in common? A negative, and let's keep the negative with it. And when we factor that negative 3 out, what are we left with? Or plus 1. Good. Okay, so now, because they have that in common, the 2q plus 1 gets its own set of parentheses. P minus 3 gets its own set of parentheses. So that's what this would look like up there. Yeah, Lydia? It should, if that is the correct way of factoring, yes. Yes. Rachel?
Yesterday there was one like just like that, but it didn't match up.
That one I believe was 42, which there may have been an issue with. Yeah. Most of them should work out okay. That's just why I said, yeah. Marcy?
For questions with multiple terms, if you have one term on the numerator of one fraction and then multiple terms on the numerator of another of the second fraction, do you just do the distributive property to each term to each like member of that term?
I'm going to have to come look at what you're talking about. Is it a homework problem?
Well, yeah, but I mean, I think it's just.
Okay, do you want to go ahead and give me what you're looking at?
Okay,
We can look at it.
So
So for people who are good and you feel like you have an understanding, this is the homework assignment. I'm going to answer Marcy's question. But everybody else can start working on the homework if you're ready. So go ahead, Marcy.
Okay, so like 12a squared 6 times.
Wait, 12a squared 6?
I mean x.
X. Okay.
Did I say 6?
Go ahead. Keep going. Hey, you guys don't talk till the camera is still rolling. Do not talk so that people can hear. Go ahead.
Yeah, it's a cube. Oh, it's a cube. My bad.
Okay.
But anyway.
This is number 6 on the homework.
Yeah.
Okay. Go ahead.
Times 2a plus 3 over 4a.
Okay, so there's nothing under the 12a cubed x?
No.
Okay.
So I'm pretty sure that you could cross multiply the 4a and the 12a, right?
Yeah, you can. You can reduce those right off the bat.
So after that, I got that it was 2a squared, or it was.
Okay, I'm gonna stop you right there. Let's just go through this problem. Okay, so if we are reducing these two terms together, 12 divided by 4 is 3. And that becomes a 1. We have 3 a's on the top and 1 on the bottom, so we end up, when we reduce, get 2 of them left over here. So here's what we end up with after that all happens. We have 3a squared x, you can leave it over 1 if you want or not, times 2a plus 3, like that. Okay, so yes, every term over here, if your question was, does every term get multiplied? Yes, it does. So you would have to distribute this to what's in the parentheses. Does that help? Questions? Yeah.
You have to distribute.
You don't, yeah, I would, if I was in your position, I would not distribute, since this is, you can, and it's an equivalent expression, but I would not.
So that's our answer.
That would be your answer, correct. Other questions? Okay.